Let's now consider two more examples of generic classes in Java. Specifically, we're going to consider what you're really supposed to learn from the first year ArrayList and also Hashtable. I'm not going to repeat about exactly how these two collections are going to work, but instead I'm going to focus more about declaring the generic parameters and also using them. If you got any doubts about how to use them, I'm going to include the links to the first year lectures for your information. You should really review them if you got any doubts. Otherwise, you can skip them. All right, I'll leave the choice to you. All right, let's now first of all talk about ArrayList. Right, ArrayList is going to be like a resizable array, but you just got the various methods you can call. Right, let me just show you one thing. If you want to look for the complete information for ArrayList, you can simply maybe Google and Java API ArrayList. If you go there, one thing I want you to pay attention to right away. This will be the declaration for the ArrayList class. And if you remember the book class, right? So now we can see the similarity. So what we're doing is we're declaring this public class ArrayList. And then we're saying that somehow for declaration purpose within the scope of the ArrayList class, we're going to use the parameter E. E can be instantiated into any concrete type, like maybe string, maybe dates, or maybe any other valid type. Okay, and another class I want to before that, and of course about how to explore the API webpage. It's something I assume you already learned about in the first year. If you got any doubts, you can reach out to me. I can point to you some reference. And you can see under method summary over here, we got many methods there that are actually available to be called on any context objects of type ArrayList. And I'm going to talk about a little bit some of them just as a reminder, and then to explain, for example, what does it really mean when we got E over here. So now you can think about this E is like a return type, which uses the generic parameter E that we saw in the beginning of the on the top of the page, which is this type parameter, and it's similar to in the get method for the generic book, which also returns E, right? So that'll be the first class we're going to review. The second class you can also look up for its information is a hashtable class. The hashtable class is just go a little bit more go with a little bit more extension. So you can search for Java API hashtable, right? If you go there, you will see the class declaration over here. So one thing to note, you can declare more than one generic parameters if needed. So hashtable is such an example generic class. So if the syntax will still be the same as before, so we got left angle brackets and also right angle brackets. Within that, you can simply got a comma separated list of generic parameters. So this means, for example, if we go to the method summary over here, we can either refer to the V, the second generic parameter, or we can also refer to, let me see if I got an example here. We can also refer to, let's say here for the parameter, we can also refer to the first generic parameter, right? The type. All right, so that's about some extra information you can definitely look up to really explore yourself. But let's now return back to the slides to give you some more focused illustration for the example. Let's now switch to iPad and do some illustration. Let's now start with the ArrayList. And you can treat this line over here as the declaration of the type parameter E. Okay, so that would be the first note I would like to make. You can think about the E over here is more like the declaration of generic parameter. Generic type parameter, if you like. That's the complete name, which can be used for declaring types within the scope for the ArrayList class. And I'm just presenting some selection of the methods. Right, let's take a look over here. For example, you can see this return type E over here, and also this return type E. And let's see this method parameter E. And of course, Java API doesn't usually show you the attributes. Attributes are supposed to be private, hidden from us as the user. So you only see return type and also parameter type. And let's see if I miss anything here. Okay, also here, right? Right, also parameter type, right? All these are actually making use of the generic parameter. Okay, so let's now be very precise. And once we clarify this, and then I can just point to you how you're supposed to study the example. Okay, let me just draw a little bit better. Put this line here. Okay, so all these are uses E for type decoration. And we got 4 examples over here. We got method parameter, and also we got method return types over here, right? As soon as you actually instantiate this E by any valid type, for example, string, person, points, or whatever valid type, in that case, every occurrence of the usage E over here is going to be replaced by that particular type you're declaring. For example, let's say this. Let's just to make the point clearer. If I got ArrayList, let's say I have a class called points. Okay, let's call this one list1, right? Of course, as I said before, behind the scene, there should be a separate copy of the ArrayList being created behind the scene by the Java compiler. But for now, for illustration, let me put on the same copy, right? So now for the green one, so every occurrence of E is going to be replaced by the point over here. So this is going to be point, and this is also going to be point for the 2 return types, and also for the 2 parameter types. They're also going to be replaced by the point. All right, let's just take one example here. So now if I got list number 1, of course, assuming that you already created a new object for that, so it's not null, right? If I try, for example, list1 dot, let's say, let's take the let's say this one here. Let's take this method, right? When you want to add, you should really pass a point, right? List1 dot add, right? So let's assume P1 is actually a point objects, all right? So this one for sure is going to be valid, so check, right? On the other hand, if I say list1 over here dot add, see what I'm doing here. Maybe say hello. Is this going to compile? The answer is no, it is not, because list1 is the context object over here. And in which case, every occurrence of E has been replaced by point already. So if we talk about this add method over here, it is expecting a point for the argument. So string is not a descendant class of point. So that's why it is not going to compile. On the other hand, I want to show you the contrast. If I just got another variable decoration, so you really want to judge decoration by decoration. ArrayList, and over here, let's say simply string, right? And let's call that list number 2. And of course, let's say you already initialized the list 2 to some non-null objects for the list. Let's now simply copy these 2 lines exactly, right? So I'm going to say list number 2 dot add the same P1, right? Assuming that P1 over here and here are referring to the same reference variable of type points. And I'm going to say also list number 2 dot add. And over here I'm going to say hello, right? You can see the same string literal hello and also hello. So now what would be the validity checks results for this, right? Here you can see add P1, but the context object is actually list number 2. And here, every occurrence of E is going to be replaced by actually string, right? So that means I'm going to have, let's say, put string over here, right? And specifically for this method over here, the E will be replaced by a string, meaning that we are really expecting a string arguments in the case of a list 2 being the context object. So that's why this is not a string, so it is not going to compile. You can, right? And also similarly for this one here, hello, it is indeed a string. So that's why it is going to compile, right? You can see the main point I'm trying to convey to you is we're calling the same method add over here, and we're passing the same arguments, right? But depending on the type of the context objects over here, list1 versus list2, they are declared to be both array list. However, the generic parameter E is instantiated differently. One is instantiated to be points, meaning that for this method add, for example, is going to be expecting point. On the other hand, for this list2 declaration, the generic parameter E is instantiated by string, meaning that for this add method here, for example, is going to expect string instead, right? Just make sure you understand about this logic over here about declaration and instantiation. And this will be the example code, which I'm not going to go over in detail, But I think for those of you who actually got any doubts about how the basic methods or the common method for array lists should work, I will include the links at the end of the lecture slides, and then you can refer to them, right? That's something you were expected to know, actually from the first year. For here, I just want to show to you one thing which maybe you got a little bit confused, maybe from the first year. So here, as soon as we say array list over here, right? And we are using string over here. So the string over here, that means we are instantiating the E by string. Meaning that behind the scene, let me just make a copy of this, okay? And then I'm going to do something very similar to what I did for the generic book, just for completeness. Okay, I'm going to paste it over here. So behind the scene, there is a consequential copy of the array list, right? The font size is a little bit small, but that's okay. So over here, this part over here, right? So this is really the consequential copy of the array list class after we declare this particular line over here. Okay, let me just write it down. So this is really the consequential copy of the declaration array list, where the E is instantiated by string. Right? It's really important for you actually to see that point again, to be reinforced. Okay, and to be more precise over here, let's see. Every occurrence of E is going to be replaced by just string. And E here, E here. Okay, and also E here. Okay, all of them will be replaced by string. So let's take a look at maybe one or two methods to make sure. So now if I say list contains A, right? So where is the contains method? The contains method is actually, for example, contains method is a bit special. You can see here we are expecting just objects. That means anything will be okay. So this is just a declaration from the array list class, right? I didn't make it up. Let's see another one. What about we try the add over here? If I go to the add method over here, so this should also compile because you can see this is a string arguments. And if you look at the add method over here, and that one should already be instantiated by string. So that's why it will match. So string is a descendant class of string. So call by value, right? Okay, so that's about the connection I'd like to draw. So study this example in two respects. One is what I just talked about, just to see how the instantiation of E by string here actually will work in terms of the consequential copy, and then check for every method call about the array list and make sure they really compile, right? That's number one. Number two, and also to make sure how you can visualize about how the array list will actually work. That's something I will include some supplemental materials for you. That's actually from the first year, so I don't need to repeat what we are supposed to learn in the first year. Okay, so that's the first one. Let's talk about the hash table also very quickly. The case of the hash table will be very similar, except that we now got two generic parameters over here, right? So when you declare the hash table class, so we actually got two type parameters, which is okay, right? You just have to make sure when you instantiate the hash table, you want to know which one is instantiated by what. Okay, let's just take one example here. So where do we use K and V, by the way? So where do we use K? Let's see K first. So you can see we got K here. For this selection of methods I included, this is the only place I use K, but that's okay. What about V? So we use V here, we use V here, we use V here, and also we use V here, right? Let's just take one example. If I say hash table, okay, hash table, let's say maybe I want the key to be a string, and then maybe I want the value to be a person, right? Just for example, let's say person. And then I'll say T1 for table number 1, right? You can also initialize that to be a new object. You can refer to the example code to see how to do that. Let's say in this case, so we know that the string is actually going to instantiate the K over here. So that means every occurrence of k is going to be replaced by string. Similarly, let's see, what about the v, the second generic parameter? Person is going to be used to instantiate the second generic parameter v. So that means every occurrence of v is going to be replaced by person. Okay, so what I'm doing is I'm producing the consequential copy behind the scene for this particular decoration for T1, right? So it will be as if for the type of T1, we actually declare the following hash table class headers, like the method headers under the hash table class, right? So you can see the return type for get should be a person, corresponding to the person over here. And the first parameter for the put method here is going to be string, corresponding to the string over here. Okay. Let's now move on to, it's a very long lines of code. Again, it's just about some example usage for the hash table. So I'll let you study how it should be visualized about its functioning. I'll let you do that, but let me now just mention very quickly about how the generic parameters will be instantiated, and look at maybe a few lines for checking the validity. So this will be the first generic parameter, right? Oh, actually, let me look at the decoration itself. So look at this line here. So this is the decoration of the table for grades, right? You can see this part over here, string, is going to instantiate the first parameter, right? And the string over here is going to instantiate the second parameter, which is a string over here. Let me now create the consequential copy very quickly, and then we'll check maybe just a couple of lines, just for example, and then we're done. Okay. Again, you can check at the end of your lecture slides about how the lines of code will actually can be visualized to work, right? And I think I'm running out of space, so why don't I just make it okay, maybe I don't want to make it too small. How about just up to here, right? You can definitely refer to the entire coding from your lecture slides. Okay, let's now take a look, right? This will be the consequential copy, right, from the decoration. Right, for this one here, actually k and v will just be instantiated into string, as opposed to what we got before, string and person, right? So you got two examples here. So v over here is going to be replaced by string. I'll say s for short. And also the v over here also will be s, and k also happen to be the same, just string. All right, that's the consequential copy. Let's now take a look at, for example, if I say grades.put Alan and A. Alan here, so we talk about the put method, which is over here, right? You can see Alan matches string. A over here, string literal, also matches string. So that's why this line here should really compile. Okay, let's now take a look one more. Let's see here, grades.remove over here. Okay, so remove is actually over here. So this one here has nothing to do with a generic parameter, because you can see the parameter is simply just objects. So that's the design for the hash table class in the Java library. So now Alan is definitely an object, so that's okay too. All right, so that's about the example for hash table. Right? The main lesson to learn here is really to see how the generic classes can be used by looking into the decoration for the variable. Right? It's very important. Let me now go back to the slides, right? We have just gone through the method summary, a selection of method summary, and also example code for array list, and also we got hash table, and also example code, right? Let's now take a look at one more exercise about generics, okay? Let's see this. Let's go revisit our example for the book, right? So let's say, remember we got a generic book, and this part here can be instantiated by any type, right? Like a dates or maybe a string. But what if we got just objects over here? Should this be a good design, right? Should this be an appropriate choice for the element static type for the array internally inside the book? Should this be, or should it be not? You can pause the video and think about it. The answer is no. But why? Well, think about what's really happening over here. If you actually got objects over here, that means every occurrence of E is going to be replaced by objects. Agree? Let me now go back to the generic book, which is over here. If I say every occurrence of E is going to be replaced by objects, so that means this part here is also going to be replaced by objects. This part here also by objects, and the return type also by objects. Isn't this just identical to the original general book declaration over here? So that means when you are using the generics in Java, you got to be careful about instantiating the generic parameter. For example, E. If you simply instantiate it to something too general, like an object class, you're really not doing yourself any benefits by using generics, because having the general book over here, we know will suffer from what we said before about the typecasting instance of checks, which will severely violate this single choice design principle, right? Let's now go back to the slide to just conclude. Okay, it allows all kinds of objects to be stored because the E will just be replaced by objects. So we're just going back to the very general book, right? All classes are descendants of objects. We can just store anything into the book. So when we retrieve anything, when we retrieve something from the book, the only thing we can assume is it is actually objects. So we are not really improving the situation. Right, so you can read it through about this exercise over here. So it has a very simple point and straightforward point to really carry through to you. Whenever you're using generics, just remember why we are doing this in the first place. We really want to avoid typecasting and also instance of checks because they will violate the single choice design principle. But if you simply instantiate a generic parameter by something that's too general or something that has too many descendant classes, in that case, you're not really improving. All right, that's think about this exercise over here. Simple, but it does have a point. Right, what about beyond this lecture? Let me point to you several exercises. Number one, you can actually go through this link. Click on this link. There's some official documentation about Java generics. You can definitely explore further if you wish, right? Just for your knowledge. And you want to play with the source code example books, which I made available to you. So if you go to Eclipse and then example books project, if you expand it, you will see under the source, we got general book versus generic book, right? I also leave the implementation part actually just empty. So that will be the exercise for you. So how should you implement it, right? Just remember back in the iPad notes, in the very beginning of the lecture, I actually draw this visualization over here about names and also records, right? At the corresponding indices, you should really have the name with its corresponding record. So that's what you should do to maintain the two arrays. So that'll be some exercise for you to really complete. Okay, and also you got generic book, and really pay attention to the syntax, right? For declaring the generic parameter and also how to use them, right? Complete the exercise. If you got any trouble, let me know. All right. Let me now go back to the slides. Okay, and one more exercise for you. You can also review the basic array list and also hash table methods, right? So you can I'm including my earlier lecture in the winter. So just about in the first year, how you're supposed to use the array list methods and how you're supposed to use the hash table method. Specifically, the two example codes I showed to you, I only showed to you how the generic parameter E has been instantiated or how the K and V have been instantiated. I didn't go into detail about how to visualize array lists and also hash table workings. So you should really refer to these two videos if you're not too sure about how they work, right? You will be expected to know later. All right, so that's about the end of this lecture about generics. Let's now move on to the next topic for the week.